While LLM offer impressive generality and conversational fluency, the majority of agentic subtasks in developed agentic system are repetitive, scoped, and non-conversational, calling for the models that are efficient, predictable, and inexpensive. In this context, SLMs not only suffice but are often preferable. They offer several advantages: lower latency, reduced memory and computational requirements, and sufficient and significantly lower operational costs, all while maintaining adequate task performance in constrained domains. Our position stems from a pragmatic view of language model usage patterns within agentic architectures. These systems typically decompose complex goals into modular subtasks, each of which can be reliably handled by specialized or fine-tuned SLMs. We argue that insisting on LLMs for all such tasks reflects a misallocation of computational resources, one that is economically significant and environmentally unsustainable at scale. Moreover, in cases where general reasoning or open domain dialogue is essential, we advocate for heterogeneous agentic systems where SLMs are used by default and LLMs are invoked selectively and sparingly. This modular composition, combining the precision and efficiency of SLMs with the generality of LLMs, enables the construction of agentic agents that are both cost effective and capable. Ultimately, we observe that shifting the paradigm from LLM centric to SLM first architectures represents to many not only a technical refinement but also a human moral ought. As the AI community grapples with rising infrastructure costs and environmental concerns, adopting and normalizing the use of SLMs in agentic workflows can play a crucial role in promoting responsible and sustainable development. I really don't know what this is. We'll figure this out. Okay. Coming on to section 3, position arguments. We support three views, V1 till V3, by the following non excessive arguments. Uh, 3.1, SLMs are already sufficiently powerful for use in agents. A1, SLMs are sufficiently powerful to take the place of LLMs in agentic systems. This argument stands in support of view V1. Over the past few years, the capabilities of small language models have advanced significantly. Although the language models scaling remains observed, the scaling curve between model size and capabilities is becoming increasingly steeper, implying that the capabilities of newer language models are much closer to those of previous large language models. Indeed, recent advances show that well designed small language models can meet or exceed the task performance previously attributed only to much larger models. Extensive comparison with large models have been conducted in the individual works cited below, but not all capabilities assessed by benchmarks are essential to their development in agentic context. Here we highlight that aptitude for common sense reasoning, an indicator of basic understanding, tool calling, and code generation, both indicators of ability to correctly communicate across the model tool/code interface. See figure 1. Uh, figure 1. Okay, so this is figure 1, will come here. And instruction following ability to correctly respond back across the code model interface. In each case, we also quote the efficiency increase if stated by the authors. Microsoft Phi series, Phi 2.7 billion parameter model achieves common sense reasoning scores and code generation scores on par with 30 billion models while running 15x faster. Phi 3 small 7 billion parameter model achieves large language understanding and common sense reasoning on par with and code generation scores running up to 70 billion parameter models for the same generation. NVIDIA Nemotron H family. The two 4.8 and 9 billion hybrid Mamba transformer models achieve instruction following and code generation accuracy comparable to dense 30 billion large language models of the same generation at an order of magnitude fraction of the inference flops. Hugging Face Small LM2 series. The Small LM SMOL LM2 family of compact language models with sizes ranging from 125 million to 1.7 billion parameters each run up in their language models. Tool calling and instruction following performance of 14 billion contemporaries while matching 70 billion models of 2 years prior.